For our first example of calculations involving income streams, we're going to start with the relatively simple example of a constant stream. Now, this may seem basic, but it is a realistic business scenario because if, for example, let's say you're selling a consumable business product, something like printer ink cartridges that have to be replaced on a regular basis and that aren't subject, to seasonal variations like a surge in sales around holidays, then this is what you would expect once your market has reached its market saturation point and your sales have stabilized. So before we get into calculations, I do want to be clear about a few things. First, the function that we're given here, right? We'll call it P of T equals 100,000. Right? This function does not describe the actual income. It's the rate at which income is coming in, which you can see right here in the units, dollars per year. So we can't just evaluate this function, for example, at t equals 3 and get the total sales after 3 years. Okay, so um, also you need to be careful about the units in questions like this. The income rate is given in dollars per year, but the time frame we were given is in months. Right? Before we can do any calculations, we need to get these values onto the same basis. So I'm going to go ahead and just replace this 6 months with 0.5 or half a year. Okay, now we can start talking about answering the question and finding the total income earned. So to do this, we need to add up all of the little individual incomes from each individual little time slice here on the graph. So just as we've done in previous applications we've talked about, adding up those values means evaluating the integral of the function, the integral P of T dt from 0 to 0.5 over the given range. Now, if you're a little uncomfortable with that, right, given that our function is actually the rate of change rather than the actual income, then try thinking about it this way. Right? Remember, this P of T is actually the rate of change of the income. Right? So instead of calling it P of T, let's call it DI dt, right? The rate of change over time of the income. And this equals 100,000. Now, if you think back to the first semester class, this is a separable differential equation, right, which we know how to solve. I can move the dt over to the other side, and this becomes di equals 100,000 dt. And we can solve this, right? We can solve this. I'm going to integrate both sides from 0 to 0.5. 0 to 0.5, 100,000 dt. Now, the left side, this is I of t from 0 to 0.5. And what is that I of t? That isn't the momentary income at that time. It's the total income up to that time, right? So if I put 0 in there, that's going to be my income at year 0, time point 0. And when I put 0.5 in there, that's going to be my total income earned after half a year. All right, so on the other side, this is 100,000 evaluated from 0 to 0.5. Okay, so on the left side, this is I of 0.5 minus I of 0. And the right side is 100,000 times 0.5 minus 0, right? So that's just a half. So the right side is 50,000. And the right side, the total earned at one point minus the total earned at an earlier point, that's the change, right? So this is the change in income, which is another way of saying the total income earned over that period. And then we flash back over here just for checking purposes. If I actually just went ahead and did this integral that I originally said, we'll notice that is going to be exactly this integral here. Right, so this does give us the result we want. And just for checking purposes, if you really want confirmation of this, that we're on the right track, given that the income stream is constant, you can really treat this as just a very basic algebra problem, right? The unit time times the time is equal to dollars. And if you just multiply 100,000 by 0.5, yeah, that's exactly what I ended up doing here. Right, so basic example to start off with, right? But a good one because it gave us all sorts of different ways to confirm that what we're doing makes sense. Okay, now let's switch up a little and bring this more formally into the calculus material. I'm gonna stick with this $100,000 constant income stream for the rest of this lecture, and we're going to assume a 5% return, and we're going to assume that it's compounded continuously. So we're really kind of looking for that upper bound on what kind of income we can expect. So the question is, what would be the present value of the stream, assuming the returns are compounded continuously? Well, we've got a formula, right? We've got a formula for present value. The present value is equal to the integral of e to the negative RT times P of t dt. All right, so let's put some numbers in here. That P of t is 100,000. It's a constant, so I'm just going to make my life a little easier. I'm going to bring it out here where I don't have to worry about it. I'm going to integrate from 0 to 0.5 because that's still our time frame. And let's see, so this will be e to the negative 0.5 t dt. Okay, well that's a pretty straightforward integral to do. This is 100,000 divided by negative 0.5 e to the negative 0.5 t. We're going to evaluate that from 0 to a half. So what do we get over here? This is negative 2 million, I believe, 6 zeros, 2, 1, 2, 3, 4, 5, 6. E to the negative 0.5 times 0.5 minus e to the negative 0.5 times 0. That's nice. That's going to e to the 0. That's going to be 1. Now, if you go to your calculator and do the arithmetic here, this comes out to $49,380.18. Right? So that is the total amount that we would have to put in an account today, earning this much compounded continuously, to at the end of a half a year have that same 500,000 was $50,000 that we calculated on the previous slide. And there, if you want to just do a quick reality check, yeah, this is it is less than 50,000, which we would expect because the interest is what's going to bring it up to that level. And it's not a whole lot less. 5% is an okay interest rate, and 6 months is not a very long time. So yeah, I mean, just from a reality check basis, that's a realistic result. Okay. Next question. Suppose you're getting this same return, same investment, everything stays the same here. Only now, instead of the present value, I'm asking to find the future value. Okay. Two different ways we could do this, right? There's two different approaches we can take to this. All right. One of them is just use our formula, right? If we use our formula, the future value is e to the rm integral 0.5 p of t e to the negative rt. So this is 100,000 e to the negative 0.5 t dt. All right, so if we I should have put them in here on the left side too. This with the e to the rm. This is e to the 0.5 times 0.5 times this integral, 0.5, 100,000, e to the negative 0.5 t. Okay, well, I want to point something out at this point, right? This integral right here, that is the exact same integral we did on the previous slide, right, to find the present value. So this is e to the 0.5 times 0.5 times that present value amount that we already calculated. Well, if you put that number in here and you do the calculations, this comes out to $50,630.24. Right, that's method one, using the formula. Another method we could have used here, and it really is kind of what happened in this integral anyway. Right? Another method we could have used to calculate the future value is to remember what the definition of present value is. Right? The present value is the total amount I would have to put in an account to equal the future value from the investment. Right? So in other words, I could just use our compound interest formula that we talked about a couple lectures back. This is the present value that we calculated previously. R is 0.5, T is 0.5, and yeah, look at that. We ended up in exactly the same place. Right, so that future value formula is great. If all you need is the future value, go ahead and use it. If for whatever reason you've already calculated the present value, then you can save yourself some trouble. Right? You can just use this continuously compounded interest formula instead. Okay, so I've got one more question here. Suppose you're getting a constant income stream of $100,000 per year. Same question. What interest would have been earned in the previous example? Now, this is one where I see students, they sometimes really go off on a wild tangent. There's not a whole lot to be done for this question. Right? Remember that money comes into this account from two places and only from two places. There's the money you put in, whether it's the present value thing, whether it's the money that you're actually getting from the stream, whatever. There's the money that you put in, and there's the money that you earn in interest. Right? So at the end of the day, the initial investment, the principal, plus the income is equal to the future value. Okay, well, and I know these things, right? The future value, that's what we just calculated, is $50,630.24. So that's plus the income. Now, this P, that's how much you put into the account. It's not the present value. Okay, this is actual dollars that you have in your pocket and that you're putting in this investment. That's the very first number that we calculated, right? The actual dollar income coming from your customers. So this is just that $50,000. Subtract that from both sides. Your interest is $630.24. Okay, so that's a fairly straightforward problem, right? We were able to do all of those calculations by hand, which was great. In the next lecture, we're going to look at another example of how to use these formulas using something called the logistics function. Right? It's going to give us a way to think about the income stream that you get from a product that has been newly released. Right, something that's going through this phase where it's acquiring customers and sales are increasing rather than having reached that steady state that we were talking about in this question.